we first need to understand the challenges faced by farmers in India. In India, the technology is not yet that advanced for the farmers to analyze their fields through satellite communication, etc. Farmers do not know which part of the field is to be irrigated properly and which part of the field is in urgent need of fertilizers and manures. All this leads to more cost production. And hence the farmers do not even know which crops are being attacked by pests, insects, weeds, etc. This leads to less yields and less incomes. Farmers are not able to pay back the loans that they had borrowed from local money lenders, traders, and banks in return for seeds and farm equipment. Farmers are called andatas in India, but the andatas themselves are not able to feed their own families due to lesser incomes. In certain extreme cases, farmers do commit suicide in certain regions. Hence, Garud is the solution we believe in. Garud 1.0 is an IoT and AI based system that will help the farmers in many ways possible. It consists of a UAV that surveys the field and sends relevant data to a series of algorithms which thereafter show probable predictions through the app to the farmers in the regional dialects. A total of 3 machine learning models will be required for this purpose. In addition, Garud 1.0 also connects the farmers to agricultural research institutes and the traders. While we explain the Garud 1.0 system in this video, this will be divided into 4 parts, namely the design, electronic components, app and the AI models. This is an ornithopter design based on flapping wings mechanism resembling an eagle. This itself reduces the threat from aerial disturbances such as birds. Thereafter, we have chosen NACI 4412 as an airfoil and we have trimmed the wings for noise reduction. The flapping mechanism will consist of conventional 4-bar drive linkage with spars made up of carbon fiber due to its high tensile strength and lightweight. The conventional gearbox used for a T-shaped tail in an ornithopter will be used in Garud. There will be 2 motors, a brushless motor of 1200 kV for the flapping mechanism and a servo motor for the tail. An ornithopter tail solves the following purpose. Some of the main electronics will be TNC 4.0 for flight controlling, ESP32 PicoKit for mobile app and the gyroscope. Garud will be using Pix4D Mapper, Pix4D Capture and Pix4D Survey from Pix4D Fields and Parrot Sequoia camera, which is famous for its multispectral imaging and high picture quality. For weather predictions, Garud will be using Omron environmental sensors connected to the ESP32 PicoKit. And this being Garud's main battery source, which is the lithium polymer battery, this will be connected to a Joule-Thie circuit for increasing the duration and serving as a power reserve. And finally, we have a flowchart describing how all the electronic components will be synced together in Garud.
Walking alone, the streets are empty. The only thing I can see is my own silhouette.
The Garud app is an integral part of our product. When a farmer buys a Garud ornithopter and decides to transform his farm into a smart Garud farm, he gets unique login credentials which he can use to log into the Garud app. The app provides several benefits to farmers and has been designed keeping in mind ease of use for the farmers. The app has an option to select language and will be supporting a large number of languages in regional dialects so that we can cover a maximum number of farmers. The app UI has been kept extremely simple and elegant. We have also built an actual prototype of the app and are going to display a quick demo of it. This is the login screen and the farmer can log in here with the unique login credentials which they are given when they buy a Garud ornithopter. After logging in, the farmer is taken to the very simple home screen which looks like this. We have decided to not show a lot of data on the home screen to unnecessarily confuse the farmer, but have kept it clean. The timing when Garud drone last collected data from the farm is displayed along with a bunch of other simple information like the farm's location, current crop season and a small notification in case any urgent action is required. Clicking on the hamburger menu button displays the full menu. In the hamburger menu, the farmer gets a wide range of options like change language, view farm statistics, choose drone settings, view live feed of farm, etc. This is what the farm statistics screen looks like. Here, the farmer gets to see the AI generated data created by processing the raw data collected by Garud drone and comparing it with ML models. Data is also represented pictorially for ease of understanding for farmers. If a disease is detected, relevant treatment procedure for the disease is shown along with other important information. Now let's go back to the menu and check the drone settings options. The drone settings give us the current drone connection status, battery remaining, along with the option to turn on or off the different modes such as survey mode, security mode, etc. So this was the basic version of the Garud app.
Furthermore, Garud 1.0 uses a deep learning model to detect plants diseases. This model is built using computer vision, Keras and scikit-learn modules on Python. It uses a dataset called New Plant Dataset, which contains over 87,000 RGB images of healthy and diseased crop leaves categorized into 38 categories. This deep learning model has yielded a training accuracy of 88.16 and a test accuracy of 75.79. As you can see, we have used only 100 images from each category for training because of the limited computational capabilities of the environment we are working on. Increasing the amount of data will definitely increase the accuracies to a significant extent. We had also planned to build a deep learning model using similar approach for analysis of multispectral images of the field as well as for high detection of the crops. Unfortunately, we could not find any public dataset to fulfill our purpose. Here, we have tested out our model on the images of the leaves of some diseased plants. As you can see, the prediction of our model is given along with the ground truth for each of the images, and the accuracy is quite high.